Hi my dear students, welcome to Chemistry SR, our chemistry channel. In this video, we are going to discuss about the dynamic nature of equilibrium. What is meant by dynamic nature? We know one thing, during a chemical reversible reaction, an equilibrium will establish. Once an equilibrium is established, both the forward and backward reactions takes place with the same speed. Such a state is called equilibrium state, right? Okay, but at equilibrium state or when an equilibrium is established in a reversible reaction, we were noticed one thing: the color, concentration, density, pressure, volume, such properties are remains constant. It means if you observe the reaction mixture, there is no change in color, there is no change in concentration, there is no change in pressure, no change in density, everything remains constant. Now you felt like this, the reaction is stopped at equilibrium. So it seems to be reaction is stopped, but actually a reversible reaction never stops at equilibrium. Continue to takes place in motion. That is called dynamic nature. So we can conclude one thing: the chemical equilibrium is dynamic in nature, but we have to prove it. So now we have to demonstrate the dynamic nature of equilibrium by taking an example of Haber process. So let's see. Initially we know one thing: at equilibrium, both the rate of forward is equals to rate of backward. It means continue to takes place. Okay, it means at equilibrium both the processes continue to takes place. Okay, it means we can say one thing: the equilibrium or chemical equilibrium, is dynamic in nature. Dynamic means in motion, continue to takes place, nothing but in progress. Okay, but we have to prove it. Let us take an example of synthesis of ammonia by Haber process. We can demonstrate the equilibrium, nothing but the dynamic nature of equilibrium. See how. Let us take a vessel having nitrogen and hydrogen. For example, nitrogen gas combines with hydrogen gas to give ammonia gas. The obtained ammonia dissociates to give N2 and H2 back. So an equilibrium will established for this reaction mixture. So this is the vessel 1 which contain this reaction mixture. Nothing but this vessel contain nitrogen gas, hydrogen gas and ammonia gas. These three gases are present in this vessel. An equilibrium is established. Let us take the isotope of hydrogen, deuterium, for the synthesis of ammonia in another vessel. So N2 and D2. What is D2? D2 is deuterium, the isotope of hydrogen. So we get ND3. Okay, same thing, but instead of hydrogen we are using deuterium. This is the reaction mixture present in the vessel 2. This vessel contain nitrogen gas, deuterium and then deuteroammonia, ND3. Deuteroammonia, nothing but ammonia. Instead of hydrogen there is the deuterium atoms. Okay, so deuteroammonia. So these are the two equilibrium mixtures. One is ammonia, another one is deuteroammonia. If you mix these two, and here after some time both vessels get equilibrium mixtures. After some time this reaction reach the equilibrium, this reaction reach the equilibrium. It means in both the vessels contains equilibrium mixtures. Now, if these two mixtures are mixed, nothing but a vessel initially it contain, when these two are mixed, contains nitrogen, both vessels contain nitrogen, hydrogen, deuterium, okay, nitrogen here, hydrogen here, deuterium here, ammonia, NH3 and ND3. So these are the components present when these two equilibriums are mixed. Okay, clear? Then if you think at equilibrium the reaction stops, this vessel contain, these are the components, after some time there is no change in the components. Okay, here you mixed the same composition of two equilibria. Now after some time if you analyze the reaction mixture, ఈ రియాక్షన్ మిక్చర్ నేను అనలైజ్ చేస్తే, దిస్ రియాక్షన్ మిక్చర్ కంటైన్స్ నైట్రోజన్, హైడ్రోజన్, డ్యూటీరియం, అమ్మోనియా, డ్యూటీరో అమ్మోనియా. If reaction starts at equilibrium, there should be no change in the composition. Clear? But actually you notice one thing, nitrogen, hydrogen, deuterium, ammonia, deutero ammonia and NH2D, ND2H, HD, these are the components also present. So HD, hydrogen, deuterium, NH2D, 2 hydrogens, 1 deuterium, ND2H, 2 deuterium, 1 hydrogen. So these are the components present after some time in reaction mixture. What it indicates? At equilibrium reactions are not stopped, and moreover the concentration of ammonia and ND3 doesn't changes. Here what are the concentrations present in NH3 and ND3 are same here also. Nothing but at equilibrium the concentration of components remains constant. So concentration constant, but new components are formed. So what it indicates? At equilibrium reaction is not stopped, which is continue to progress, so that new components were formed. So this evidence gives or tells us the equilibrium is dynamic. So the above experiment indicates the chemical equilibrium is dynamic in nature. Okay, if at equilibrium reaction stops, there should be no new compounds, right? Because of formation of new components, we can say the equilibrium is dynamic. Nothing but reactions never stops at equilibrium. They continue to take place, but with equal speeds of both forward and backward. This is about dynamic equilibrium. I hope you understand. If you understand this, please like and share to someone, but keep watching. Thank you.